So, very good afternoon to all. I welcome you all for this our lecture of industrial hydraulics and pneumatic. Okay. In the morning, today's morning, we have discussed. We have started direction control wall. Okay, and in that direction control wall, we have seen what are the direction control wall. Then it's a classification we have discussed, and also we have discussed some types of the wall direction controller. In that we have seen check wall, under check wall, pulpit type check wall we have seen. Then we have seen the pilot operated check wall also. Okay. Again, position wall I have started. Second type of the direction controller, that is position wall. And I have discussed that the function of this position wall is to control the introduction of the fluid to the lines of the system. Okay, to control the introduction of the fluid to the lines of the system. Okay, when the wall is operated, that time liquid lines within it are shifted. Okay, within it shifted, and this position wall are usually described by the following two relation. Okay, positions wall are described by two relation. One is the number of ports and second is the number of position. And for that I have given the one example also. For example, 4x2 4x2 direction control wall. Now 4x2 direction control wall means what? 4 means what? Number of ports, and 2 is the number of positions. Getting it? Now again, to represent or to designate the ports, okay, again we have some designation. So if ports are working, ports are under ports, if working lines are there, then that time its a designation should be capital A, B, C, like that. Okay, and if ports are of pressure supply or the power supply, then it is indicated by the P. And if ports are return line or exhaust port, then it is represented by REST. And so again in that, if hydraulic system is there, that time return or exhaust line, it is represented by the T. And if pneumatic system will be there, that time it is indicated or designated by R and S. Okay, and if your control lines are there, that is pilot lines, then it is designated by capital Z, Y, X, and so on. Okay, so these are just some designation of the representation of the ports. Now let us go for the wall symbols. Okay, wall symbols we will see. Okay, now as we know that direction control wall has 2 or 3 working positions generally. Okay, working positions for the direction control wall, generally it has a 2 or 3 working positions. Now in that again, they are normal or zero position or neutral position. Okay, zero position or neutral position. Okay, normally they are or normal position. Okay, and working position also they have. Okay, such as retraction or extend position. Okay, again it is necessary to differentiate between the neutral and operating position. Okay, we should differentiate which is one zero position or the neutral position and which is a operating position. So in differential in directional control walls with a spring return, then neutral position is defined as the position to which the wall return after actuating force. Okay, that return after actuating force has been withdrawn. Okay, then in all this fluid control system, wall position can be represented by terms of by letters of small a, b, c, d. Wall positions. Okay, you can represent by a small letter a, b, c, and so on. Okay, and with zero means what? It is a zero position or the central neutral position. Okay, and the starting of the initial position is there. No, that position is taken up by the wall. Okay, due to the spring or in case of the spring actuated direction controller. Okay, after installation that position. So there are some wall position. Now how to represent wall. Okay, so for that purpose again we have the standard wall symbols. Okay, so here I have shown that basic wall symbols and their description. Okay, so wall position, you can see wall position, if it is a square, then a wall position is represented, actually wall position it is represented by the square. Okay, wall position. Then number of then if two position wall is there, no, that time it is represented by this symbol. Okay, two square, that means two position. Wall position it is indicated by the only square, and two square means what, two position. Okay, and in that again small letter a and b, that means number of square is equal to the number of distinct position, that means two positions. Okay, and that the value can take up, and therefore the figure shown is the what are the symbol I have shown, it is a two position wall. Okay, and further three position, and now a and b means what, these are the uh, uh, working positions. Okay, a b c, and zero means what, that is neutral position. A three position, here you can see first one, three position means what, three positions are there, under that again two are working, one is neutral, so three adjacent square indicates the three position wall. Then flow path, you can see wall position is the square, and in that arrow, that means it indicates the square, and the line indicates the flow. Okay, and the arrow indicates the direction of the line, indicates the flow, and arrow indicates the direction of the flow. That means it is going in upward direction. Likewise flow shut off, you can see the, it is cut off of fluid flow. Okay, it is represented by this one symbol. Then initial convection, this is a position. Then see how to represent that 4x2 position wall. You can see here 4x2. 4 means what? Number of ports. 2 are the position. So 2 square I have taken. Now 4 means what? Number of ports. So A, B, P, T. Okay. That means A and B are the working lines. Okay. P is the power of pressure supply. T is the, here I have written, T is the return of the exhaust line. Okay. So this is a 4x2 wall. Okay. Two position means what, A and B position, small a and b, and capital A, B, P, T, these are the four ports. Then 4x2 wall. Okay, again 4x2, if it taken in position like this. Okay, in position A, if the fluid is delivered from port P to the port A. Okay, you can see the arrow also in position A, that means first one, the fluid is delivered from port P to the port A, getting it, and returned from port B to port T. Okay, and in position 3, what will happen? Flow is reverse, that means A to T and P to B. Okay, then 4x3, 4 port, 3 position. So you can see the 3 ports also, getting it, 4x3. Now wall actuation, actually now whatever the above symbols I have shown no in above in previous slide, so that are that symbols are used in the hydraulic circuit. Okay, no need to draw the schematic diagram or the actual figure. If you take the just it's a symbol, it is fine. Okay, these are the hydraulic symbols, ISO symbols, which are used in the hydraulic system or hydraulic circuit, and this corresponding symbol having unfilled, if suppose here, if this corresponding symbol having unfilled arrow heads, no, this arrowhead, if it is unfilled, then that means that symbols or that element it is used in the pneumatic circuit. So what are the symbols are there? These are the common to hydraulic, circular, pneumatic, but arrow should be unfilled for the pneumatic circuit, getting it. Then wall actuation symbol. Okay, so to obtain the complete wall symbol, okay, wall actuation symbol must be combined with the above basic wall symbol. Okay, so here I have shown the figure. It shows the symbol for the various ways in which wall can be actuated. Okay, various ways in which wall can be actuated. Okay, so here I have taken the 3x4. Okay, sorry, 4x3, 4 port, 3 position, 4x3 wall is there. Okay, now to actuate this 4x3 wall, what are the different methods that I have represented with this wall actuation symbol? So you can see, you can actuate by actuate this uh, wall using the push button or by plunger, then by pedal, by lever, by spring, by solenoid, by roller, then by hold position is there, then pressure line pilot also. So these are the standard symbols which are used for the wall actuation. Getting it? Okay, please have a look. Actually, the actuation sort is a method of moving the wall element from one position to another. Okay. Getting it? Now here I have shown the complete graphic wall symbol. Complete graphic wall symbol. So this figure, okay, it describe that the how these various symbols can be combined to describe the complete wall operation. Okay. So here first figure is there that represent the pedal actuated spring return to the central 3x2 wall. 3x2, 3 positions are there. You can see position is what? Sorry, 3 ports A, B, A, P, and R. These are the 3 ports, and these are the 2 positions. So 3x2 wall is there, and in that again it is paddle actuated. That means here symbol it is used of the paddle, and it is returned by the spring. So it's a spring ball. You can see spring. Okay. And second is the 4x3. See, 4 ports are there and 3 positions are there. Okay, but it is push button operated. You can see push button operated and spring return to the center. Spring return to the center. Okay, so these are the symbols. Getting it? So in these are the some symbols which are used to represent the wall, complete wall. Getting it? Whether you got or not, understood or not, these are some basic symbols, okay, which are used in the direction control or hydraulic and pneumatic circuit or system. Okay, that 3x2, 4x2, 1x1 I'm going to discuss. Don't worry. Whether am I audible, my video is visible at your end, my screen is visible at your end, please tell me. Just give the confirmation message at chat box. Please give me confirmation message. Only 1, 2, 3 students are giving message. Other students, please. Everyone, please write up just yes, no. Okay, so that I can assume that you are at you are in class only. Okay, virtual class. Okay, this complete graphical wall symbol. Now let us go for what are the different methods of the actuation for the direction control wall, DCV. Okay, which are the methods of actuation. Okay, so in order to respond to the system requirement, we must provide a means of the actuation to the our hydraulic control wall. Okay, correct. So again, for example, here I want to clear that to move the spool in a position. Okay, spool means yesterday we have seen to move the spool in a position wall, or to change the setting of a pressure controller, or to adjust the flow controller, we need some form of actuation. Getting it? So form means what? The different methods of the actuation, and there are different types of the actuation method, and out of that there are the mainly 4 actuation methods are used in our control walls. Now which are that 4 that will I'm going to tell. So in that, first one is the manual actuation is there, then mechanical actuation is there, then electrical actuation is there, and fluid actuation. Getting it? So here I have shown the graphical representation of different mechanical actuation. Okay, sorry, manual actuation. Okay, so push button, it is represented by this one. Then this is lever operated, paddle operated. Okay, so these are the manual operated actuation mode method. Okay, actually this manual actuation method, it requires action by the operator, who must make a that control judgment based on upon some system requirement. Okay, push button. Okay, so this manual actuation, it includes the lever, push button, and the pedal. Okay, please see this symbols. Huh? This push button is like this, lever, pedal. Okay, see this plunger operator is there, then spring operation is there, operated. Okay, air operated, it is shown by this one. Solenoid operated, it is shown by this. And if air and solenoid, if it is combined, then it is represented by this one, combined air solenoid operated actuation method. Okay, getting it? Now that combined one more, oil or fluid, no, sorry, oil or air, so that can be used to provide fluid power for the actuation of the valve. Okay, it is called the pilot fluid. Okay, and that solenoid operation means what? It is electrical actuation. Now let us go for the classification of position valve. Okay, now we are not familiar with the position means what and port means what, and how it is represented. Okay, so we should know in detail about that also. So firstly I will tell the classification of the position valve. So our position valve are classified in terms of the number of fluid port and the number of valve position. Getting it? So based on that, position valves are classified into the 4 types. In that, two-way, two positional valves are there. Okay, two-way, way means what? Port. Two-way, two position means what? 2x2 position valve. Direction control, all are the direction control valve. Then three-way means what? 3 ports and 2 position, 3x2 valve. Then four-way and 2 position valve, that means the 4x2. Then we have the four-way, 4 port and 3 position, 4x3 valve. Okay, and so on. We have the 5x2 and 5x3 also. Okay, like that. So we have this, these are the different types. Now let us go for the, firstly we'll discuss the 2 position valve. Okay, 2 position valve. Okay, now under this 2 position valve, firstly we'll go for 2x2 direction control valve. 2x2 direction control valve. Okay, so with the help of this figure, I will discuss the construction and operation of 2x2 direction control valve. Okay, 2x2 means what? 2 ports and 2 positions. Getting it? 2 ports and 2 positions. So you can see this is a schematic diagram of the our 2x2 direction control valve. Here you can see we have the port A and port P. Getting it? So P means what? Pressure supply or power supply port, and this is A port, it is working. Okay, okay, and it is a poppet type check wall is there. Okay, poppet type check wall, correct? Because here poppet means the ball it is used. Okay, this is a poppet type check wall is there, no, like that is a this is a position type, 2 position. Okay, so you can see here actually this 2x2 that construction and operation of the this 2x2, it is similar to the puppet type check wall. Okay, whatever we yesterday I have seen, I have discussed the same. So if in position 1, what happened when push button, here push button is there, when push button is in normal position, okay, that means first position, that time spring and your fluid pressure, you can see this spring and this fluid pressure force this ball in upward direction. Okay, in upward direction, that means this one. Okay, and therefore this flow is blocked. Getting it? As I have shown in this A position, orbit position. Then suppose when the pressure of the push button, see, push button is in normal position, but in second position what happened? Push button is pressed. Okay, that time this push button pushes the ball of its seat. Okay, of its, that means here we'll get the passage. So from port A, port B, fluid will come, it will go in upward direction and it will go by this port B. Getting it? So here we have the two position. One is this one and this is two position and two port. Getting it? 2 by 2. Okay, and it's standard symbol. See, it is spring return, push button operated. Okay, so here push button, it is represented like this, spring return, and two ports, sorry, two positions are there and two port. Okay, this is a normal position. If you press this push button, then this connection between the A and P, it will start, and then from fluid will flow from P to A. Getting it? So this is a graphical symbol. Okay, this is push button operated spring return type 2 by 2 direction control valve. Okay, push button operated spring return type 2 by 2 direction control valve. Okay, okay. Now regarding this, I will show one small video. Okay, wait. It will be easy for we are to understand. Two by two. Okay. Sorry, I'm not sure the screen.
In this video, I explain 2 by 2 direction control valve. So in this image you see the one directional control valve is a spool type and second one is the rotary spool type. Means both are the spool type, but one is the sliding spool and second one is the rotary spool types. So I explain these both the types in this video with their symbol. So first we understand the 2 by 2 sliding spool type. Sliding spool means the spool is slide. Okay, and in a rotary spool the spool is rotate. So that is the basic difference between them. Now what these 2 by 2 is indicate? Okay, so first 2 is indicate the 2 port is used, and the second 2 is indicate that is a 2 position is the possible. Okay, means in a one positions the fluid is supplied from one port to another port, and second position is the stop position. Both the valves are closed. So this valve has a 2 port and the 2 position of the spools, right? I already explained the first 2 is indicate that is a 2 ports, and the second 2 is indicate that is a 2 position. Suppose the next type is the 3 by 2, then the first is 3 letter. 3 means that is a 3 port is used, and the 2 position is there. That means it is a 3 by 2. The 2 port are inlet port A and outlet port B. Means that is a port name is given. One port is known as the inlet port A and the second port is known as the outlet port B. So here you see this image of the 2 by 2 sliding spool types. Okay, so this part is called as the spool. Okay, and this is called as the push button. And here you see this is the port A and this is the port B. Okay, so this is the inlet port A. Here we mention inlet port A. Okay, so this A is inlet port and B is the outlet port. Means working fluid is enter from these sides and deliver from these sides. And this is the second position is used. Okay, so in a first position you see this is a closed valve. Means the fluid enter from the port A is not supplied to the port B. Means it is the normally closed type valves. And when we press this spool by this push button, at that time we achieve the second position, and here you see that the spool is moved. Okay, here the spool position and spring position is different. When we push this button of the spool, we achieve the second position. In the second position, you see the port A is open. So what amount of the oil or a compressed air is coming? Suppose it is a hydraulic system, then oil is come. Suppose it is pneumatic systems, then the compressed air or a gas is coming. So it is entered in port A, and from the A it is supplied to the B port, and from the B port it is supplied to the further hydraulics or a pneumatic systems. And here you see this is the symbol of the 2x2 directional control valves. Here you see that is a 2 square is drawn. Okay, means for the first position 1 square is drawn, and for the second position the second square is drawn. Suppose it is a 3 position, means second digit is 3, then we need to draw the 3 square. Okay, but here the 2 position is there, that means we draw the 2 square. And here you see this oil is coming from the A port and arrow is in upper direction, means it is supplied to the B ports. Okay, and this type T type of the symbol is indicate the both the port is closed. Okay, means here in a first position you see the A and B are closed, means for this position, means for this diagram the position correct is this second position here. Okay, and in this case you see the fluid coming from the A port is supplied to the B port. Okay, for that we draw the one vertical arrow in a upper directions. Okay, this is indicate the spring types. Okay, so here you see the spring is provided, so this is the symbol of the spring, and here you see this is the symbol of the push button types. Okay, so these are the different types of the lever is used to operate the directional control valve that we already studied in a chapter 1, that is the various types of the symbol used in hydraulic and pneumatic systems. The figure show a sliding spool. So here you see this is a sliding spool, and this spool is the spring return types. Okay, that's why the complete name is mentioned, sliding spool spring return type normally closed 2x2 DCV. DCV means direction control valve. Okay, why it is mentioned normally closed? Because in a normal condition, normal means when we are not push this button, at that time valve is normally closed, means the fluid enter in A port is not supplied to the B port, it is called as the closed position. So when we not press this switch, at that time the fluid is not supplied, that means the valve is closed, that's why it is a normally closed type valve. In a normal position of a spool, the port are closed. Working fluid cannot flow from port A to port B. When the plumb button is pressed, means it is pressed by our hand, and the spool is moved to open the passage. So here you see when we press, so here the space of the spool is changed. Okay, the spool is moving inside. Okay, and when the spool is moving inside, so here this open the passage of this port A. So here whatever thing is written, the spool is moved to open the passage from port A to port B, and hence the working fluid move from port A to port B. So this is the end of the sliding spool valve. Now we understand the rotary spool types. Now before moving it, I request to like the videos as well as in a card bin on a top right, request to visit the playlist. Type 2x2 direction control valves. The figure spool. Rotary means they spool are rotated. Okay, by using the
Okay.
In most air and hydraulic fluid power circuits, valves are used to control the direction, rate, and pressure in fluid lines. Control valves for these functions.
So in this video, they have shown the animation. Okay, how the two position means how it is achieved, and what are the ports. Okay, we will see.
Functions can be purchased with either manual or solenoid actuators. In a manually actuated valve, the internal cylinder is shifted by hand using a lever, push button, plunger, or other manual actuating device. By contrast, valves with a solenoid actuator respond to an electrical signal for shifting. With electrical control, machine cycles can be set up for automatic sequencing, and operator control can be exercised from a remote location. Solenoid valves are said to be either direct or pilot-operated. A direct-operated valve is shown here. A pilot-operated valve has a pilot and bleed orifice and utilizes line of the valve piston Most direct fluid circuits designed to use single solenoids are energized at the same time, waiting device for shifting. With electrical control, machine cycles can be set up for automatic sequencing, and operator control can be exercised from a remote location. Solenoid valves are said to be either direct or pilot operated. A direct operated valve is shown here. A pilot-operated valve has a pilot and bleed orifice and utilizes line pressure for operation. This is a pilot-operated relief valve. When the solenoid is energized, the core opens the pilot orifice and relieves pressure from the top of the valve piston or diaphragm to the outlet side of the valve. This results in an unbalanced pressure, lifting the piston or diaphragm off the main orifice. When the solenoid is de-energized, the pilot orifice is closed and full line pressure is applied to the top of the piston or diaphragm, closing the valve. Most directly operated valves also come in pilot-operated versions and are designated by a triangular graphic symbol. A single solenoid valve has one solenoid to assist in valve operation. The valve spool shifts when the solenoid receives an electrical signal and is energized. The valve will remain shifted as long as electrical current is applied to the solenoid. Once the electrical current is removed and the solenoid is de-energized, the valve returns to its normal position by spring force. Fluid circuits designed to use single solenoid valves must maintain electrical current in order to keep the valve in its shifted position. Double solenoid valves have two solenoids, typically mounted on opposite ends of the valve body. This type of two-position double solenoid valve does not have a spring return. When the first solenoid is energized, the valve spool shifts into the first position. Even if the first solenoid is de-energized, the spool remains shifted. This is because there is no spring to return the spool to its original position. Energizing the second solenoid will send the valve to the second position. Even if the second solenoid is de-energized, the valve will remain shifted until the first solenoid is re-energized. Since there is nothing holding the valve in the shifted position other than friction, these types of valves should be mounted horizontally. If both sides may cause the spool to become stuck, electrical burnout of the solenoid valve. Because of the centering springs, it's necessary to hold current on one solenoid or the other to keep the spool in one of its side positions. When each solenoid is energized, the valve shifts to the appropriate position. Anytime both solenoids are de-energized, the valve spool will spring to center and stop the fluid flow. Therefore, a three-position valve requires a maintained electrical signal for its operation. As before, energizing both solenoids at once may cause damage to the valve or to the system. To prevent this from occurring, electrical circuits should be designed to make it impossible to have current on both solenoids at the same time. Solenoid valves are used in both hydraulic fluid and air systems to control direction on cylinders from deceleration or speed control and pump unloading or pressure control. The physical appearance of each component will vary greatly depending on brand, size, and type, so care should be taken to reference the appropriate manufacturer's guidance when choosing a solenoid valve. Directional control valves are used to stop, start, route, and divert fluid streams without affecting the pressure level or the flow rate of the system. Directional control valves are identified by the number of ways that fluid can flow and the number of positions the valve.
Whether these videos are useful to understand you all. Whether videos are relevant to our topic or not? Whether videos are useful or not, please tell me. Give me reply in the chat box. Okay. Thank you.
Valve can produce. A way refers to the number of active porting connections called ports. This valve has 3 ports, so it is a 3-way valve. The term position refers to the number of discrete operating positions of the internal valve element. For this spool valve, one position allows fluid to flow from the inlet to port A, and a second position allows fluid to flow from the inlet to port B. Therefore, this is a 2-position valve. This spool valve has 2 ports and 2 positions. The first position allows fluid to flow freely. The second position blocks both ports. Even though both ports aren't physically blocked, the lack of fluid entering the pressure port also prevents fluid from exiting outlet port A. Therefore, both ports are defined as blocked, making it a 2-way, 2-position valve. To simplify fluid system drawings and schematics, all valves can be represented graphically. Boxes, sometimes called envelopes, are used to indicate the number of valve positions. Since this is a 2-position valve, its graphic representation has 2 adjacent boxes. Continuous lines are used to indicate fluid flow between ports. For complex valves, the ports may also be labeled. The input port is typically labeled P for pressure. Outlet ports are typically given alpha characters starting with A. Other times, the letter stands for the destination of the fluid. For instance, the letter T would indicate a port that is connected to a tank. This is a fairly simple valve, so port labels are not required. A solid arrow indicates the direction of liquid flow. The first position of this valve allows fluid to flow from the pressure port to port A, so an arrow is drawn in the first box to indicate fluid flow. A T indicates that a port, or way, is blocked or closed. This valve's first position has no ports blocked, but its second position blocks both. The second box corresponds to the second position of the valve. Therefore, 2 T's are added to illustrate the lack of fluid flow in the second position. Next, lines are drawn to indicate the normal position of the valve. The normal position is defined as the position of the valve when its spool is unshifted and the power is off. This means that any mechanical actuators, such as springs, are in their non-actuated positions. Electrical actuators, such as solenoids, are powered off. The normal position can sometimes be referred to as the unshifted, de-energized, or unactuated position. In this case, position 1 is the normal position. Therefore, the lines to indicate the normal position are drawn in the first box. On a hydraulic schematic, the lines that indicate the normal position will be connected to other devices in the system. Valves that do not have mechanical or electrical actuators do not have a normal position because they must be manually moved. When shifted, they remain in that state until manually shifted to another position. The terms normally opened and normally closed are used to describe the condition of a valve when it is in the normal position. For this valve, the normal position is position 1, which allows unrestricted fluid flow through the open ports. Therefore, this valve is a normally opened valve. Additionally, this valve is a spring return valve, meaning that after it is actuated, a spring returns the spool to the normal position. A spring symbol is placed next to the block representing the normal position. Actuators used to change valve positions can be mechanical, pneumatic pilot, or electric solenoid. To complete the diagram, the primary actuator symbol is placed on the other end of the graphic symbol. In this case, the actuator is a push button. Mechanical actuators change valve positions with springs, push buttons, plungers, levers, and cam rollers. Pneumatic pilots change valve position with a pressured air signal. Electric solenoids that change valve positions by directly moving the valve element are called direct solenoids. Electric solenoids that open small pilot valves and allow pressurized air to move the valve element are called solenoid-controlled pilot operators. Here is a similar valve to the one previously shown. It has 2 ports and 2 positions, so it is also a two-way, two-position valve. To illustrate the differences with this valve, let's build its graphic symbol. It is a two-position valve, so the graphic symbol will have 2 adjacent boxes. This valve also has 2 ports. However, in the normal non-actuated position, both ports are blocked. Therefore, it is a normally closed valve. When the valve is actuated, fluid is allowed to flow from the pressure port to port A. A spring returns the valve to its normally closed position, and a push button actuates it to the open position. Therefore, this valve is a two-way, two-position, normally closed, spring return push button operated valve. While it is similar to the previous example, the differences in the normal position make it a distinctly different valve. The most important applications in fluid power for three-way valves are for directional control. Here we have a typical three-way valve with 2 operating positions. This valve has an inlet port P, exhaust port E, and output port A. In its normal position, inlet port P is blocked and outlet port A is connected to exhaust port E. The second position allows fluid to flow from the pressure port P to outlet port A and blocks exhaust port E. The valve is also spring return and push button operated. Here is another three-way, two-position valve. This valve also has an inlet port P, exhaust port E, and output port A, but they are in a different configuration. In its normal position, exhaust port E is blocked and fluid flows from pressure port P to outlet port A. The second position, pressure port P, is blocked and allows fluid to flow from outlet port A to exhaust port E. The valve is also spring return and push button operated. Three-way directional control valves have many applications in fluid systems. One of the most common applications is for the control of single-acting cylinders. In this application, fluid is pumped from a tank to pressure port P. With the valve in the normal position, fluid is blocked. When the valve is actuated, fluid flows from pressure port P through outlet port A to the cylinder. The cylinder extends and remains extended until the valve changes positions. When the valve de-energizes, the spool returns to position 1, pressure port P is blocked, and exhaust port E is opened. The cylinder retracts and fluid flows from the cylinder through port A and out exhaust port E. From there, the fluid returns to the tank. Here's a graphical rendering of the same system using symbols as they would appear on a schematic diagram. 2- and 3-way control valves are ideal for use as directional control valves to operate cylinders or hydraulic rams, filling and draining tanks, as mechanical brakes, and even in vacuum systems. Their versatility is vital to the successful operation of many different fluid systems.
Welcome to Lunchbox.
In this video, I explain the symbol of 4x2 DCV. DCV means direction control valves, and explain the 2 type of 4x3 DCV. First type is the sliding spool
Okay, so that was about the 2 by 2. Okay, that means 2 position. This also we have seen 3 by 2. Now in the 4 by 2, there will have the 4 port and 2 position. Okay, that also we have seen. Now let us go for the 3 position wall. In that 3 position wall, 4 ports will be there and 3 positions. Okay, I will show its a symbol. Okay, okay, this was the 2 by 2 direction wall we have seen. Then 3 by 2 also we have seen. Okay, this one, please remember these symbols. Okay, then 4 by 2. Okay, see, 4 port and 2 positions. Okay, it is spool type, push button or actuated. Then a 3 position. Okay, in that we'll see the 4 port 3 position direction control wall. Okay, 4 ports and 3 positions for the actuation of this direction control wall. Okay, see, 4 port A, B, P, B and R is the okay, ports, 4 ports and 3 positions. Okay, these are different positions. Getting it? So I will show that video. 4 by 3.
In this video, I explained the symbol of 4 and the second one is the rotary spool type. So it is 4. 4 is indicate there is a 4 port is there and the 3 means the 3 position is possible. Earlier we studied all the types of direction control in which 2 position is there. Okay. So here total 3 position is there. So this valve is used to operate double acting cylinder and bidirectional motors. It has 4 port namely. So here you see this symbol of 4 by 3 direction control valves. So that's 3 position. 3 position means we need to draw the 3 square. Okay. And in every square we need to indicate the 4 ports. So here you see this port P, port T, port A and port B. And here you see this DCV is operated by the lever. So pump port P or inlet port P. So here you see that P port is provided. Then second one is the cylinder port A. Means this A port is connected with the cylinder. Means it is either connected with the cap side or a road sides. Then here the cylinder port B. So it is suppose A port is connected with the cap and road side. Sorry, cap and side. And the B port is connected with the road side. And this is a tank port T. Tank port T is connected with the tank or a reservoirs. It has the 3 position of its spools. Means for operating the DCV that is a spool is used. Okay, so that is a 3 position of the spool is possible. So this first rectangle is called as the first positions. Okay, sorry, not rectangle, it is a square. Okay, so square is indicate the first position. In a first position you see that the P port is connected with the A port, means oil coming from the P port is supplied to the A port. Then B is connected with this T. So here you see this is a downward arrow, means B is connected with the T. And the cylinder or motors move in the one direction. In another position of the spool, there is a connection from P to B and A to T. So here you see that the P port is connected with this B and this A port is connected with this T port. Hence, the cylinder or a motor runs in a opposite direction. So this is called first position, this is called second position. And intermediate position is called as the mid positions. So in the middle position of the spool, the cylinder or motor stops. It will not move in any direction. So there is a various types of the mid position is possible, but here we discuss the closed center type mid positions. So now we move towards the first type, that is a 4 by 3 sliding spool valve and closed center mid position, means we use the closed center as a mid positions. Now here you see this is a diagram for the 2 position. This is a diagram A and this is a diagram B. In a first position of a spool, position as shown in this figure A. Okay, so this is figure A, in which you see that there is a connection from P to A and B to T. Okay, so this is the valve body. This sectional view is indicate this valve body. This is a sliding spool. and the sliding spool is operated by using this push button. And here you see this is a various port is given, that is a 4 port, A port, P port, B port and T port is given. Okay, so in this 4 port there is a 3 position is possible. Okay, so this is the first position. Here you see that oil or a compressed air coming from the pump or a compressor is enter in P port, and from the P port here you see that is a passage is there, and these passages connect the P port with the A port. Okay, so what amount of the hydraulic fluids is enter is supplied to this A port. Okay, and from the B port return means suppose we use the double acting cylinder, then at the when the oil is supplied to the A port, so A port is connected with the cap and rod sides. Okay, cap and side, and the piston is moving right side, so at that time the oil pressure on the road side is coming this B port. Okay, and from this B port here you see this passage is there, and from this passage the oil is going a T port, and from the T port it is supplied to the tank or a reservoirs. So working fluid flow to the cap end port of the cylinder and comes out from the rod end port, and the cylinder is extends. In a second position of a spool position as shown in this figure B, so this figure B is indicate the second positions. There is a connections from P to B. Okay, so here you see this P port is connected with this B, and A port is connected with this T. How A port is connected with the T? So here you see that is a here passage is provided. Okay, so this A port is connected with here, means oil coming from the A port is enter in this passage, and from this passage it is enter into this T port, and from the T port it is supplied to the tank or a reservoirs. So working fluid flow to the rod end port of the cylinders. So oil coming from the P port is supplied to this B port, and B port is connected with the road side of the cylinders. So piston or a cylinder is retract. At that time the oil present on a left side, means on the cap end side of the cylinders, the oil present on the cap end side of the cylinder is supplied in A port, and from the A port it is supplied to the T port, and from the T port it is supplied to tank or a reservoir. That means the cylinder is retract. Now here you see that is a diagram C. This indicate the mid positions. Okay, so here we discuss about the close center mid positions. So when the spool is kept in the middle position as shown in the figure C, all the ports are closed. So here you see, suppose the oil coming from the pump in a P port. Okay, but this oil is not supplied to the any port, because here you see this P port is closed. So oil is not supplied to the A port or a B port. Okay, so here you see the T port is also closed, means this what amount of the oil is present on the accumulator as it is. Okay, because oil is not supplied from the P port to A port or a B port, or not supplied from A B to the T, means all the ports are in a closed condition. Here you see, suppose the oil is coming from the A port, it is not go anywhere. Oil coming from the B port, it is not go anywhere. This is closed here because all the ports are closed, and this closed center mid position is there. There is a different type of the mid position is possible according to this requirement that we already study in a chapter 1, that is a various types of the symbol for the mid positions. Now before moving ahead, I request to like the video in descriptions as well as in a card. And mid positions in a card. So if you don't know that, card mean on the top right screen of your mobiles or laptop positions. Now here you see this is a 3 positions diagram, that is a rotary spool type.
Okay, so this was about the 4x3. Now I will show some animated video. 1 minute, I just 4 we have seen.
Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com, and today we're going to be having a look at directional control valves. This will be part 1 of 2 on directional control valve basics. We will be looking at 4-port directional control valves that feature a blocked P-port when in the center or neutral position. 4-port directional control valves typically have the 4 labels P, T, A, and B. The P port is for supply from the pump, The T port is for the return to tank or reservoir, and the A and B ports are typically known as the work ports and are connected to the cylinder. Let's get started with a 4-port 2-position valve that does not have a center position. On the symbol, you see P to A porting to extend the cylinder and P to B porting to retract the cylinder. On the actual valve spool, you will see a cylindrical spool sliding inside of a cylindrical valve bore. The spool has large diameter areas called lands and smaller diameter areas called undercuts. This valve, with its 4 ports and 2 positions, is popular enough to extend and retract a cylinder, but does not allow the user to stop the cylinder mid-stroke. The spring inside this particular valve returns the valve spool to the P to A position whenever the lever is released. Notice that the relief valve is taking care of limiting maximum system pressure whenever the cylinder is deadheaded against the fully extended or fully retracted position. Now let's change to a 4-port 3-position valve. In the symbol, you can see that a center position has been added along with a second spring. The 2 springs in the symbol mean that the valve is spring-centered. Notice that the P port is blocked when in the center position. The relief valve is limiting system pressure. The A, B, and T ports are also blocked, making this a closed center valve. The machining of the valve spool shows that lands are blocking the A and B ports. The P port comes into an undercut on the spool, but flow cannot move to any other port, so therefore the P port is blocked. The T port is available on both sides of the valve spool, but again is not connected to any other port at this time, so it is blocked. Activating the valve shows us that we can provide P to A flow to extend the cylinder or P to B flow to retract the cylinder. Releasing the handle shows that we can in fact stop the cylinder mid-stroke. This is a common feature and is desired for many hydraulic systems. It is especially popular for horizontal cylinder installations, but as we will soon find out, it is not great for a vertical installation. In this animation, the valve seems to perform just fine, but can you imagine what happens as the cylindrical valve spool moves back and forth many thousands of times through the same valve bore? That's right, wear will start to occur and internal valve leakage will develop, and we will find that our cylinder is slowly drifting downward whenever the valve handle is in neutral. Now let's look at a valve that is typically referred to as a float center valve. Just as before, the P port is blocked at center position. However, the A, B, and T ports are all now connected together. Notice that the lands on the spool have been machined back to allow the B port and the A port to connect to tank during the center position. If you are watching the cylinder, you will notice that it fell all the way to the bottom. The float center literally leaves the cylinder floating freely. Believe it or not, this valve center is quite popular for vertical cylinder applications, but we need to add pilot-operated check valves in order to hold the cylinder mid-stroke. The small diameter pilot lines are not continuous flow lines. They merely provide a tiny fixed amount of fluid and the pressure needed to operate the pilot piston. When the pilot piston is extended, it allows reverse flow through the check valve. Ball and seat style or poppet and seat style check valves are usually considered a much more reliable leak-free valve, as the main components of such a valve do not wear against each other. The float center valve in this case is most desirable to make sure that the pilot lines are completely vented to tank to allow the springs inside the check valves to close the check valves completely and hold the cylinder mid-stroke. In both of the 4-port 3-position directional control valves that we studied, the closed center and the float center, the P port was blocked. The use of these valves is typical to what is referred to as a closed center hydraulic system. In many cases, our gear pump would be replaced by a pressure-compensated variable displacement pump in order to avoid excessive pumping over the relief valve. In another video, we will cover the tandem center valve and the open center directional control valve. That's all for this time. Thanks for watching.
Okay, so this is about the duration control. Now last one is remaining, this one. Okay, shuttle wall. Okay, so you can see the fluid will come from this port 1, okay, in the shuttle wall, and from port 2, okay, and it will goes from this port, okay, and this shuttle wall having the standard symbol like this. You can see here I have shown, okay, this one. And here we have the shuttle piston. Okay, if fluid will come from this port 2, okay, from this if same position will be there, no, then port 2, from this port 2 fluid will come, then it will go out of this port. And if shuttle piston will move toward this port 2, no, then from this port A fluid will come, and this from this port the fluid will go. Okay, so for that only symbol is like that. Okay, this one. Okay, so this is about the direction control. Understood or not? Please tell me in the chat box. Direction control understood or not? In the next lecture we'll see the pressure control. All of you please tell me understood. Okay, now I request you all, please write down your roll number in the chat box and you can leave this meeting. Okay, so see you tomorrow. We'll see pressure control, okay, and flow control in tomorrow's lecture. After writing your roll number, you can leave this meeting, no problem. Be fast. All are requested to write your roll number in the chat box, and after writing your roll number, you can go.